In this video, we will talk about the Vray to Nuke workflow using ACES. For this, we will export a multi-channel EXR with a customized lookup table and various other frame buffer effects to Nuke and assemble everything using ACEScg Color Space. So right here, you can see a simple scene that I set up using Vray, and specifically, I was using ACEScg Color Space to render my scene. And in this video here, I want to talk about the correct workflow of how we can export a multi-channel EXR over to a compositing software like Nuke so that we can get the exact same representation of what we can see here in our Vray frame buffer. So for this, we're going to be discussing of how to set up our render settings correctly, what kind of render elements we need, and then also how we can transfer some additional color corrections that we did here in the Vray frame buffer over to Nuke so that we can get a really accurate and matching representation of what we were rendering in here. So let's check out our render settings first, and you can see that within the settings and color management tab, I have here the RGB primary set to ACEScg, and then of course in my frame buffer I also have the display correction here set to OCR. Then I load the ACES 1.2 configuration file, and then I just dial in those settings in here. So I have the input color space ACEScg, the display device ACES, that's anyway the only choice you have. And then my view transform, of course, has to be sRGB because I use an sRGB monitor. If all of this seems confusing for you, I have an own dedicated video about how to set up correctly ACES in 3ds Max and Vray. So you can head on over there if that's interesting for you, because this goes into way more details, and I think afterwards all of this here makes a lot of sense to you. So since we want to output a multi-channel EXR to Nuke, we have to make sure that we have all of the correct render elements in order to replicate our rendering in here. And you can set up the render elements in here. Different kind of elements are provided by Vray. And in my scene, I require here a lighting element, I require a GI element, a specular element, a reflection element, a refraction element, and then also a self-illumination element in order to have my environment here show up. And all of those elements are basically required to rebuild the scene in here. And this always depends on the kind of scene that you have. So for example, if you have specific shaders like subsurface scattering shaders, then you might need to add additional render elements. Or for example, you have atmospheric effect, you would need to add an atmosphere element in order to replicate the scene that you have here in your frame buffer. But as I said, this is always individual and always depends on your scene. And in my case, basically those elements here are enough to replicate the scene. Additionally, I have a denoise element in here because I want to also show the workflow of how you can transfer denoised render data over to Nuke. And in this case, I use the Intel Open Image Denoiser, so I can have a faster rendering and still get a basically noise-free result. And what is important when you use the denoiser is that by default, it basically just denoises here your RGB color, so your basically beauty path. But we also want to denoise all of our different render elements, and for this there is a dedicated option here in each render element to enable here the denoising. So basically I went through all of the different render elements and make sure that the denoising option here is enabled for all my elements as well. So if you don't enable this denoising here in the render elements, then basically in Nuke, when you would try to replicate your beauty path based on the individual elements, then those would be based on not denoised data, and then your combined result would be the noisy result. So in this case, if I disable the denoiser, you can see that it is actually much more noisy, and then your combination would just look like this result in here instead of the denoised one. Additionally, while we're talking about render elements, make sure that in the Vray Global Switches tab, the consistent lighting element option here is turned on, because if this is turned off, then your render elements will be split up slightly differently, and then it can't really guarantee that whenever you compose them back together, you will end up with the exact same result that you can see in here. Even though I prefer the distribution in this mode in here, because for me this makes more sense of how this is split up in different kind of render elements. Make sure whenever you use multipass EXRs or whenever you try to recompose your image from render elements, to turn on this option here so that you don't end up with some unexpected results. So there would be one last thing that we have to do in our render settings. That would be to go into our frame buffer, and of course we also want to save our image somewhere. And as a multi-channel EXR, I would enable the Vray raw image file option here, and then use EXR file format in here. Let's call it 𝐕𝐢𝐝𝐿 for example. And what I like to do is to save the virtual frame buffer color corrections to the RGB channel. So those would be the adjustments that we did here in the frame buffer. Those would be saved into the RGB channel. It wouldn't be saved on the different render elements. And that is quite handy because then in Nuke we can easily compare our combined render elements with basically exactly that image that we see in here. We can see it, everything lines up correctly. So now just press save. And now let's check out here our frame buffer, what additional things we set up in here and how we can transfer those over to Nuke. So now in the frame buffer, let's analyze what we set up in here. And let's start by the display correction here at the very top. And as I mentioned already, this one is set to OCIO, just following basic ACEScg workflow in Vray. But what is important is that this save in image option here is turned off, because otherwise all of those transformations would be baked into our EXR. And that's not really what we want, because we want to basically also load here the OCI configuration file in Nuke directly and not really bake anything into the image. So make sure this option here is turned off. So now let's check out some additional adjustments that I did in the frame buffer. And those we would also need to transfer over to Nuke, and I will show you a simple workflow of how you can achieve that. So let's first see what I did here additionally in order to basically make the image the way that I wanted. Let me turn off these additional adjustments in here. You can see this one is the original rendering here with the OCIO lookup basically. And then once I enable this, you can see this makes actually quite a drastic effect in here. And how I did this was to just add here this vignetting option. So basically I use a background element that uses a vignette texture, and I just switch this to foreground. You can get some nice vignetting effects here directly in the frame buffer. And I sometimes prefer to use this option because those would not be baked into your render elements. If you do that in the camera directly, those would be also transferred to the render elements. But in this way, basically, it is only saved here in our RGB channel, in our RGB color channel, and not into all of those render elements in here. Then I have some hue saturation adjustments, some exposure adjustment, some white balance in here, and lastly some curve adjustments to basically make the picture look exactly how I want. So also I have some post effects like this lens effects in here. Let me turn this on and off. You can see I boosted that artificially a little bit so you can see the difference more clear. And what is important is to remember the intensity value in here. So by default, this one is set to 1, but in this case, I boosted it up a little bit. And you need to remember this value in here in order to make it look the same way in Nuke. So we have this here set to a value of 3. I also have some sharpening and blurring effect in here. You can see if I turn this on or off, I have a slight sharpening that's happening here. And then of course we have our denoiser element. So if I disable here the denoiser, you can see the base rendering is much more noisy, and with the denoiser that basically helps to clean up a lot of this noise in here. So now additionally from this render data that we have in here, we also need to basically transfer this stuff here over to Nuke. And the main thing here would be those color adjustments in here, and those luckily can be saved as a lookup table. So if you just right click and then save all color corrections here as a lookup table, you can save that basically here as a separate file. But what is important is that you do that in the right mode. So at the moment, this one here is set to OCIO. And if you then save out here the lookup table, this is actually not really correct. It will not really show up correctly in Nuke then. So what we have to do is to go over here to this sRGB mode temporarily and then save all of those adjustments here as lookup tables. Let's just call that LUT in here, then save this. And let's also do this here with the OCIO to just show you later on in Nuke that this one doesn't give you really the correct results. So I will call this here LUT OCIO and save this also. And this LUT basically saved those 4 adjustments which we did in here. The color adjustments, basically, those are saved in the LUT file. And there's some remaining elements which we have to think about how we would transfer this over to Nuke. So we have here this vignetting effect. That's actually quite simple because we just need to load the same texture map in Nuke, then also multiply that on top of our rendering using the same opacity that we set up in here. So in this case, the opacity is a value of 1. And then we have the lens effects, and those can also easily be transferred if you enable this save glare channel option in here. And then those would be saved here as a separate render element, and we can basically compose them back on our rendering again if you remember here the intensity value. So by default that's 1, then you don't really need to remember it, but if you have anything else set up in here, then you basically would need to set the same value over in Nuke as well. And then lastly, we have this sharpening blurring effect in here, which unfortunately doesn't really have an option to export that or to basically bake that into our render elements, which anyway we probably wouldn't really want. So we have to basically replicate the same effect over in Nuke. So now we're basically finished. We can render here this image and then switch on over to Nuke to basically recompose everything back together again. So now we're in Nuke, and as a short disclaimer, I'm not really a Nuke artist. So if there's something that is wrong or something that can be optimized, be sure to let me know in the comments. But this is the workflow that currently works for me and the one that I am using. So as a first step, let's load our rendering. For this, I will just use a simple read node and then just load our EXR, which we exported earlier. And now you can see, if we watch this in our viewer, that the colors look completely wrong. And in order to fix this, we need to go to our project settings and go into the color tab in here and then switch this color management to OCIO and then the OCIO config file to custom, because we want to use the exact same configuration file which we also did in the Vray frame buffer. So let's load that. In my case, that's ACES 1.2. And now you can see that the colors here are already correct. If they are not correct, you need to make sure that the working space here is set to either scene linear or rendering ACES, ACEScg. And now you can see that we have at least our colors from our rendering in place already. So that's a good start, but if we zoom in, we can notice a few issues. So first of all, there's a lot of noise in here, so it doesn't really seem to be displaying the denoised result. Also, the lens effects here seem to be missing. So in order to fix that, we have to make sure that we load the correct channel from our EXR. And for this, let's use a shuffle node and connect this here to our read node and then just preview this one. And at the moment it loads the RGB channel in here, but there's a bunch of different channels, the ones that we exported earlier from Vray. For example, you can check the lighting, you can check the reflection and so on. But the one that we are interested in is the effects result. And this basically contains all of the data that we basically saw in our virtual frame buffer in Vray. So we have the denoised image, we have the lens effects in here, we have the sharpening that was applied and so on. So this one here is basically now the result that we want to reassemble by basically stacking all of the different render elements together, and like this basically get the exact same result as what we see now in here. So now I went in and pre-assembled the node graph already so that we don't need to waste so much time building that. But what we have here, marked by the yellow arrows at the moment, is exactly the same setup that we had before. So we have our rendering, we have our shuffle that loads the effects result, and then we have here our viewer, and that's what we are currently seeing. But we also have a different node graph in here, the one that's highlighted now. And this one is basically the one that splits up our EXR into multi-channels and reassembles them back together, brings in our glare, our vignette, our sharpening, and all of our effects in order to basically have the same result than what was baked in here to the effects result channel. So I can switch back and forth between both of them here, and you can see you get exactly the same kind of result, even though they are assembled completely differently. So now let's start to break this down. Let's start by this daisy chain of different shuffle nodes in here. So I have my lighting element, I have my GI element, I have my specular, reflection, refraction, and self-illumination element. And additionally, I also have my glare element loaded in here. And those are all done through different shuffle node. And the glare element has an exception because this one I have to boost here slightly with this grade node. So the grade node here, I gave a gain multiplier of 3 because we also set up an intensity value of 3 in the Vray frame buffer, if you remember correctly. And then we can merge all of those together here with a merge node where we set the operation to plus. So basically everything is added together. And then we combine basically all of our render elements or render channels here together to get, as you can see, a denoised result because we denoised also all of our render channels. We also have here our lens effects and so on. So this is a good start already, but if we compare that with our ground truth, our effects result, where basically all of our adjustments are baked in, you can see that we don't really have exactly the same result yet. And the reason is that some things that we set up in the Vray frame buffer are still missing. And let's start with the vignette that we put in the frame buffer before. And this I merged in here. So I basically just used a new read node and I just loaded an EXR that has an alpha channel, the same that I also used in the Vray frame buffer. And I just merged that here on top of my assembled render elements. So you can see we have now a simple vignette effect, and that basically now brings us a little bit closer to this image. So you can see now there are only the colors which are different. The vignette now is basically in place. And I also had some slight sharpening in here. So you can see that at the moment, if I switch back between this and this, the colors are changing, but also I have some sharpening. And for this, I just added here a simple sharpen node in Nuke, and I just tried to kind of match the same sharpening amount. So you can see that here in this line, apart from the colors, I think now the sharpening also matches. So you basically just try to eyeball this in place. And now the most important step is to load here the lookup table. And this you can do through a vector field. So apply this vector field node in here and then just pipe everything through this. And now if we check this, then we can see the colors now are matching exactly. So in this vector field, I basically just loaded here the cube map, the one that we exported from the Vray frame buffer. And let's also load the one that we exported using the 𝐘𝐨𝐿 color space, just show you that this one doesn't work. So I will load this into here and then also connect this here in my sharpen node. And now if we switch back and forth between both of them, you can see the one LUT file that we exported with the 𝐘𝐨𝐿 settings is not correct, and we had to use the one that was exported using the sRGB display correction. So just as a reminder of how you need to export this basically. So now again, we can switch back and forth and we can see that we have the exact same result, just that this one here was assembled by the Multichannel EXR. And we now have all of the additional benefits of being able to completely grade here all of those different render elements separately and just go into much more detailed adjustments compared to just using here our baked effects result channel. So this concludes the workflow of how to reassemble a multi-channel EXR from Vray in Nuke, and I hope you found this useful and learned something from it. If you enjoy this kind of content and want to know more, you can head on over to my Patreon, where there's a whole course on car rendering and a lot of other additional goodies that might be interesting for you. Otherwise, see you next tutorial, take care and see you soon.